And the better you get, the more you realize that the people who are better than you are like way better than you, right? And in fact, the better you get, the more you're like daunted by like how much better the best people are, right? And I think like a lot of professions that with like a lot of, potential and upward mobility are like that. Like, in economics, the better you get at it, you're like, wow, I thought I was good, but holy crap, the best people out there are so much better than me. You know what I mean? And that's how you know that you're in an area with a fat-tailed distribution. So those are sort of the subjective things that correspond to these quantitative notions. Okay, so just to give you a graph of this, so this is what a uniform distribution looks like. You notice you're getting up here and you're like, there's lots of people like me, not so many people very much better than me. Normal distribution, well, there's a lot more people like me than people who are up here. Log normal distribution, not so clear, right? Compared to me, there's actually quite a few people out there. There's a lot of people in the tail. And a way to put this is we can graph the hazard functions. So for the uniform distribution, this goes rocketing up, right? For the normal distribution, it goes up maybe a little bit more slowly. For the log normal distribution, it actually goes down as we get larger. Okay. So all the data we have indicates that in areas that really matter, like these talents and professions, that very often things are extremely, extremely fat-tailed. Things usually follow a Pareto distribution or power law. And that's so fat-tailed that I couldn't even fit it on this graph because it would have caused everything else to get completely smushed down. This distribution has the following form. So its CDF is 1 minus the value of talent that you're at divided by the minimum talent of anyone in the market to the negative alpha. And you can't, the way that I fit these other things is I had them all have a constant mean and variance. But you can't even do that with the power law because it doesn't have a variance for most of the values. But it behaves roughly like the log normal distribution until you get to the very top. And then it's just so much more fat-tailed than the log normal distribution is. Okay, so does anyone want to talk about some ways we can think about a Pareto distribution that came out of the reading? Intuitively? Well, one way is that the fraction of people with talent greater than 2x is 1 over 2 to the alpha greater than the fraction that have talent x. So think about how fat-tailed that is. Imagine that alpha was 1, which is a case we'll focus on. That's saying that if I'm this talented, the people who are more than twice as talented as me is only half as large as the number who are more talented than me. That means it's going way, 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 way out. Another way of putting it is that the 5th most talented person is 1 over 5 to the 1 over alpha as talented as the most talented person. So again, with alpha equals to 1, that's like the 5th person is 1/5 as good as the best person, right? In that particular case, alpha equals 1 is called Zipf's law. So to give you a sense of how much more fat-tailed the Pareto distribution is relative to the normal distribution, log normal distribution as we get towards high values, if we take the inverse of the hazard rate, you'll see that initially, actually the log normal is above the Pareto. But as we get larger, the Pareto just goes way, 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 way bigger than the log normal does. Now, Zipf's law is the idea, as I said, that the best person is twice as talented as the second best person, 3 times as the third, 4 times as the fourth, et cetera, et cetera. And this fits incredibly well with many regularities in the world. So if we look at the size of firms and we graph the log frequency against the log size, which you should get a fit of 1 if it follows Zipf's law, we get almost a perfect fit in almost every competitive industry. And in fact, when you see an industry that isn't fitting Zipf's law, it's a good place to look for collusion. Because collusion gives a lot of rewards to firms that aren't actually that strong, right? because you need to keep them from breaking the collusive agreement, so you need to give them some rents. It rewards not talent and productivity, but just being part of the collusive group. And so in collusive industries, you tend to see a coefficient on the Zipf's law regression that's much flatter. So there's a job market paper. This was an observation that I made in class last year that somebody heard, and now someone on NYU is on the job market with a paper that uses this idea. And so she found these firms that were exempted from collusive rules and other firms that weren't, or groups of firms. And the Zipf's, if you run this regression, the firms that were non-collusive all had this being above 0.9, the negative, below negative 0.9, and all the other firms had it like below, above negative 0.7. And so that means that there was a much flatter relationship between your rank and how well you did than you would expect in a competitive industry. So if you see, for example, in Peru, I was on the phone this morning actually talking to their competition regulators, and they're worried about the pension fund industry. And the reason is because all the firms have basically 25% of the market over time. And you just would never expect to see that in a competitive industry, because you usually see these Zipf's law type distributions where the biggest firm is much bigger than the next, and so forth. Okay, and in fact, these power laws hold not just for size, but for income. So CEO pay scales with the 1/3 power of the size of the firms, and the firms follow Zipf's law, so the income of CEOs follows a power law with a 1/3 power. And more broadly, income follows a law with alpha somewhere between 1.5 and 3. It's a little bit more unequal than the CEOs, actually. So this is sometimes called the Pareto Principle, that like 20% of the country will control 80% of the wealth. So this is also relative for comparative advantage across countries, and we're going to talk more about this on Thursday. So some broader takeaways from this is that talent, income, and other social differences are very large, especially at the top. And that things like normal distributions, which might be convenient things from a statistical perspective to use in some cases, are just wildly off when you think about the top end of the distribution. Any model that ignores this and has anything to do with what's going to happen in the extremes is going to be radically off in many, many cases. And that's true for financial models about events that occur, as well as it's true for models of people's talent. So if you base your assumptions about what happens in the financial world on a normal distribution, you see what happened in 2007, 2008. And there's a very natural reason why that should correspond to this, which is that the largest industries in an economy, when they suffer a shock, that's going to be much, much worse than when smaller industries in the economy suffer a shock. And so if you think that the economy as a whole is made up of shocks to different industries, you should expect to have these fat-tailed distributions of outcomes. Heterogeneity is particularly at the top end of an industry. It's not just the people select in, but that the people who select in are even more diverse than the people who don't select in. And that there's some simple empirical regularities, which are actually very convenient to work with analytically, that do a pretty good job of capturing this idea. And they can really simplify down analysis of these cases, and you'll be using that in your problem set. Okay, now Zipf's law applies to lots of things. One thing that it famously applies to is cities. So if you take the log of the rank of a city in the country's size, and you regress that against the log of the size of the city, you should get a straight line with a coefficient 1 if Zipf's law fits well. And here's what it looks like for the cities in the United States. It's pretty amazing. China, it fits much, much better because they have even more cities than we have. And so forth. It's really amazing how well this fits. It also applies to words in the English language, citations of papers, citations of economics professors, lots of things this applies to. So this extreme heterogeneity raises a lot of questions. So one is that rents must be quite important even in the long term. And this undermines a lot of the classic free entry logic. So if we go back to our superstar effect, why is that so common relative to the free entry story? Well, it's because the talent distribution is so dispersed at the top that it makes a lot of sense to concentrate things among the most talented. Free entry, I think, in some ways is actually more of an anomaly, which intellectual property can help us to address. So it's not really that most industries are free entry industries, and therefore we need intellectual property. Actually, we should think the normal thing is that we have a situation like this, and IP is the way that we restore incentives to a situation that fails to do that. If some firms are so much bigger than other firms, is Bokhar here? Bokhar Ba? No. If some firms are so much bigger than other firms, our assumption that firms are price takers is going to be pretty problematic, right? Because if you have one firm that's that much bigger than the next firm, it's going to be very hard for there to be a lot of firms in an industry, right? So market power, once we start thinking about things that way, is going to be a much more important feature of what goes on in different markets. Also, this is, yeah, Mohammed.
So you said that firms usually, the firm size go through power law. So,
yeah.
And we had the idea like power law means like if alpha is equal to 1, firm is only 1/5 of the largest firm.
Yeah.
So like this statement,
yeah.
that if there is a firm that's larger, very larger than other firm,
yeah.
that should be true in like the real world, that we have power law distribution of the firms.
Yeah.
But still, like, so that doesn't that negate your conclusion here?
No. Not necessarily. I mean, there could be a lot of firms, and that could still hold, and you could still get a pretty competitive market. It's just not that likely.
You just said if you have like a firm that's much larger than the others, there's not much small firms in that industry.
No, but it's not going to be a very, at least there's going to be one firm that has market power, is what I'm saying. Now that's not necessarily true, because if there's a ton of firms, then it still could be that no firm has market power, but it's going to be very likely, it's going to be much more likely in this setting than in the standard free entry setting, at very least, that there's going to be at least one firm that's very large,
so
and therefore has market power.
Is not a true situation for all industries, because you said like overall and within each industry, the power distribution.
It's true in both cases.
All industries, because each industry that...
Well, the size of industries also sort of follows a power law. So it is possible that all these things can work that way. I mean, it's an amazing regularity. And it leads to a lot of inequality, naturally. And more inequality as technology advances, because the best people are able to reach more people, right? And so that makes redistribution very important. It also means that by raising taxes on the wealthy, we can, because there's so much space between one person and the next person, we can generate a lot of revenue by just taxing the people at the very top, right? And so we'll talk a lot about that when we discuss income redistribution. And so in some ways, this fact summarizes a lot of the concerns we're going to have throughout the rest of the course and motivates them. If we really were in this world of the classical free entry whatever, many of the things we're going to talk about wouldn't be so relevant. But because we're in this world where there's this huge heterogeneity, these concerns about market power, about redistribution, are going to be really central to how I want to think about a lot of issues in the rest of the course.
You think that heterogeneity is basically in productivity, or it also applies to, say, preference, like risk attitudes?
I don't think there's a lot of heterogeneity in terms of people's risk attitudes, no.
So in production?
Yeah. Anyway, I finished a little early today because I finished a little bit late last time, so hopefully that balances out. Thanks.